Welcome, fourth grade. We are not doing a Eureka math lesson today. For the next 2 days, you're going to be practicing your multiplication and your division skills. And today is all about you. What is your favorite way to multiply? And let's practice that way. So for today's video, we're going to practice 3 strategies that we've learned for doing multiplication with 2-digit by 2-digit numbers. After you've practiced these 3 strategies, when you add a response and practice those problems, you get to choose which method feels most comfortable for you. Grab your math notebook and open up the table of contents because today is called 1-21. That's today's date. And we're going to call this lesson multiplication practice. Then you'll want to find your next blank page. I'm going to move on from this in about 5 seconds. So if you need to pause your video, you need to pause it right about now. Like I mentioned, we're doing 3 strategies today. We're going to start with the one that takes the longest, and then we're going to slowly break it down until we're doing the most efficient one, our newest one, the standard algorithm. So the first method I'm going to start with, you can see right here next to me, is the area model, specifically the area model where we're adding up 4 partial products. And we're going to model the area model with 4 products using this sentence right here. So take a moment and in your notebook, draw an area model where you have 4 separate compartments and the number sentence 54 times 23. The purpose of the area model is to take a multiplication sentence and expand it into smaller pieces that make us feel more comfortable. Like, for example, with the numbers 54 and 23, we can use this square to model its multiplication. We can find the area of this square where one side of the square is worth 54 and the other is 23. But we need to expand these numbers. If we left it as 54 and 23, whoop-de-doo. We just end up where we started, multiplying the 2 together. That doesn't make it simpler. What was the point of drawing this box? So let's expand 54 and 23 into numbers that are easier for us to multiply. 54 expanded into its tens and ones are 50. And I'm going to mark 50 with this long piece of the area model. And 4. When we expand 23, we have 3 ones and 2 tens. Like so. 23. Take a moment and fill out your area model as well. Now that you have these pieces filled out, we're going to solve the partial products for each of these squares by writing the multiplication sentences that find its length and width. I like to start with my smallest square because I feel like my smallest square is going to be the easiest to solve. My smallest square means I'm multiplying my smallest numbers, 4 times 3, which means one of my partial products over here will be 4 times 3. 4 times 3 is 12. So my first partial product is 12. Take a moment and label your first partial product inside of your number sentence. Next, I like to do my larger box because for me, it's the easiest to keep track. Smallest numbers, biggest numbers get multiplied in this box. My 2 largest numbers are 50 times 20. Which means that my other partial product will be 50 times 20. I'm skipping a line because I like to keep my partial products that are next to each other in the number sentence, and since these are opposite sides of each other, I just put it in a different space. When we add it up, it won't matter, but I just like that organization better. I don't know 50 times 20, but I definitely know 5 times 2. 5 times 2 is 10. And when I have 2 more zeros inside of my number sentence, I can put those 2 more zeros inside of my answer for a grand total of 1,000. So our next partial product is 1,000. When I write these, I'm being really careful to line up my numbers so when it comes to adding them, they'll be nice and clean and ready for me to add. Okay, for my next partial products, I have to multiply a big number times a small number because this rectangle has a large side and a short side. So this one's going to be 50 because it's 50 across times 3 because it's 3 in length going down. Five times 3 is 15. Put another 0 at the end of my number. That means my partial product is 150. One more to go. One more to go. Lastly, I also want to multiply a large number by a small number. So I'm going to multiply 20 times 4. 2 times 4 is 8. With the additional 0 at the end, that makes 80. So now take a moment to add up all 4 of your partial products and come up with your answer. Now, if you don't want spoilers, then you better pause me because I'm going to reveal the answer in 3, 2, 1. We have an answer of 1,242. That was one strategy. And we're actually going to go faster from here because each strategy gets more and more efficient as we go. So find some room in your math journal because we're going to move on to another problem. Now we're going to do the area model, but this time we're going to narrow it down to just 2 partial products. And we're going to do that by eliminating one of the columns that we had in our area model. So we just have 2 compartments, one for each of the partial products that we're going to be adding up. You'll notice, Mrs. Schumann, this is the same problem. Yes, it is the exact same problem. The reason why is that if we're using the same problem, you can really truly compare which one do you like better. It's not that one number sentence was simpler than the other. It's truly what strategy do you love the most? So let's practice using 2 partial products and an area model. The difference between the last area model and this one is that I'm not going to expand the number 54. Instead, I'm only going to multiply 54 2 times. I'm going to multiply 54 times 3, which is how many ones I have, and 54 times 20, which represents the tens that I have. 54 times 3 I can solve by using my standard algorithm skills that I've practiced all quarter long. 3 times 4 is 12. 3 times 5 is 15. Plus 1 more is 16. So I know that my first partial product that I'm going to be putting into my number sentence is 162. I'm going to do the same thing again this time, only I'm going to multiply 54 times 20. Ugh. I don't like that. I don't like those double digits. I might not know 54 times 20 off the top of my head, but I bet I could use my multiplication skills to solve 54 times 2 and then simply put a 0 at the end of my answer to represent 20 and give that a try. Four times 2 is 8. 2 times 5 is 10. If I multiply everything I have by this group of 10, I'm going to put an extra 0 at the end of my answer. 1, 2, 3, whee! For a total of 1,080. Being very careful to line up my place values. You guys know the drill. If you want me to spoiler alert it, I'm going to reveal the answer in 3, 2, pause to solve independently. Have one more second to do it. I'm not even sure how much of a spoiler alert you needed because we got the same answer that we did the first time, 1,242. And as you can tell, that one was a quicker method as well, and we're only going to get faster and more efficient from here. We're going to try out one more strategy, and that's our standard algorithm. And when we solve with a standard algorithm, we're not going to use an area model at all. We're only going to be using our math multiplication skills and our simple number sentence to figure it out. So find another space in that math journal, and we're going to do a brand new method of solving. You guessed it, we're doing 54 times 23. Why? We already know the answer. Well, the reason is because we want to compare the strategies, not the number sentences. We want to make sure it's really truly our favorite strategy, not just our favorite number sentence that we did that day. But you'll notice I have taken down our area model. Why? Because you won't need it for this method. When we multiply using the standard algorithm, we're going to create two partial products by just knowing our math facts in our head. Now we want to multiply one place value at a time. So I find it helpful to keep a handy dandy post-it note near me, because when I multiply one place value, I want to pretend like the other one doesn't even exist. And the only thing I need to worry about is figuring out this number sentence right here. So let's start with our ones. 3 times 4 is 12. I can't put all 12 down there, so I'm going to regroup. 5 times 3 is 15, plus one more is 162. There's no more for me to multiply in our ones place. So it's time for me to move on to finding my next partial product, which is in the tens place. So now I'm going to pretend like I can't see this 3. And the only thing I care about is the number 2. So I'm going to cover up this 3 like so and get rid of my regrouping mark from my last time. Now, before we do anything, keep in mind that this 2 doesn't just mean 2. It represents 2 tens. It's in the tens place. So where this pink post-it note is, really, it's like an invisible 0. So before we do any multiplication, let's put the number 0 in our next partial product, because anything we multiply, we're multiplying by 10. 2 times 4 is 8. 2 times 5 is 10. And now it's time for us to add. You know the drill. You can do the addition on your own, or you can come back in 3, 2, 1. You know it, you love it. It's 1,242, just like the last few were as well. So here's what's going to happen next. You're going to have 4 problems to practice in your response. That's it, just 4. And you get to decide in those 4 problems, how do you want to answer it? Are you going to use your area model with 4 products, your area model with 2 products, or are you going to use your standard algorithm like I did here? As part of your assignment, you're also going to upload the notes that you took during this lesson. If you feel like you're not totally comfortable with standard algorithm yet, that's totally fine. You've been doing it for what, a day? When you come back to small group later today, we'll be practicing some more standard algorithms, so you'll feel a little bit more comfortable with it. All right, good luck, give it a shot. Send me a picture of your notes and add a response to do those problems.